So we can use this proportion for the Jack and Jill problem for trick-or-treating. We can use this proportion to make a table of values. So at half an hour, we were able to get through 30 houses. At 1 hour, we calculated 60 houses. At 1.5 hours, we're going to be at 90 houses. Okay, at 2 hours, we're at 120 that we calculated. And basically, we're going up by 30 houses every half an hour. So that is definitely a rate, because if you look at the problem, 30 houses in half an hour. Sorry, 15 houses in half an hour. So I think I've made a mistake here, didn't I? Okay, so we have 15 houses in half an hour, 30 houses in 1 hour. Okay, 45 houses in 1.5 hours, 60 houses in 2 hours, 75 houses in 2.5, okay, etc. Okay, so when we fill that out, okay, we can plot the graph here. So at 1 hour, we're going to go up to 105. So 1, 2, let's say that's 10, 20, 30, 40, 50, 60. So at 1 hour, we're going to be at 30 houses here. Half an hour, we're at 15. At 1.5 hour, we're at 45. 2 hours, we're at 60. 2.5, we're at 75. 3 hours, we're at 90. At 3.5 hours, we're at 105. And I want you to notice that if I look at the pattern of this really is a straight line pattern that goes through 0, 0. And in fact, if you take a look at these ratios, 1 to 30 here, 1 to 30, okay, 2 to 60, 3 to 90, these are just equivalent proportions. Okay, these are equivalent proportions here. In fact, all of these are equivalent proportions. Okay, and oops, I should have done that. All of these are equivalent proportions, and when we have these all in proportion like this, we end up with a straight line that goes through the origin 0, 0. In fact, we're going to get back to that later on when we start looking at something called slope. So this idea of proportion is actually related to this, what we call the slope of this line. And this is what we call direct variation, because these are the numbers in the table are actually proportional to each other. They're just equivalent proportions. Okay, these are all the same in the same ratio. Okay, and that is a characteristics of these direct variations, or these straight lines that go through 0, 0. Okay, not only has to be straight, it actually has to go through 0, 0 for it to have this property. So there it is. This idea of proportion, okay, shows up in something called slope. And I'm going to just show you the parts of this slope. Okay, we have 1 hour here. Okay, this is what we call the run, the change in the x. And vertically, it's like a staircase. Vertically, we have here 30 houses. Okay, so this is what we call the change in the x and the change in the y. And this ratio of change is actually what we call slope. So 30 houses in 1 hour, and slope is a ratio. It's actually a ratio of these two terms. So we can come up with a formula then to express the number of houses visited as a function of time. So the number of houses, okay, is going to be what we're calculating, and I'm going to call that y. And we can calculate that by 30 houses per hour times the number of hours. Okay, and it looks like this, 30 times x. Okay, where 30 houses, in fact, maybe I should write this properly as a ratio. That ratio is going to look like this, 30 houses for 1 hour, okay, times the number of hours gives us the total number of houses that we visited. And the equation simplifies to y equals 30x. So here we have a map. The map scale is 5 kilometers to 2 centimeters. We can write this scale as a unit ratio. To find any unit ratio or multiplier, we divide. So if I do 5 kilometers to 2 centimeters, I divide that, I get 2.5 kilometers per centimeter. Okay, so there's my unit rate. We can also write that unit rate the other way around. So we could say 2 centimeters, I'm going to put or, 2 centimeters for 5 kilometers. And if I divide that, I get 0.4 centimeters per kilometer. So every kilometer represents 2.4 centimeters. So city A and city B are 6.3 centimeters apart. How far apart are they in real life? Okay, so we can set up an equivalent proportion to solve this. We could also use a time strategy, but this is asking us to show a proportion. So I'm going to use maybe the one we had here. Okay, 5 kilometers to 2 centimeters. And that's equivalent to, well, the 6.3 centimeters goes on the bottom. And we have to solve for that top. And I know that I've already divided these two numbers, and my unit rate, or my multiplier, is times 2.5. So I'm going to use that multiplier times 2.5 to solve this problem. And I end up with x equals 6.3 times 2.5, 15.75 kilometers. Okay, so there's how we can solve this with an equivalent proportion. We're going to do this next one here. We could have done this, the B, using our multiplying strategy, or unit conversion strategy, or unit analysis. So, but we're going to show that unit analysis for this next problem. Okay, so we have to start with 47 kilometers, and we want to know how far in map distance we're talking about. So I'm going to start with 47 kilometers, and then I have my maps ratio, my rate. This is my rate. I can use that rate as a multiplier if I know how to set up the ratio. Okay, I need to make sure I know which is on top, which is on bottom. So I need to get rid of kilometers, so I know that I put the 5 kilometers on the bottom and the 2 centimeters on the top. The kilometers cancel out, and I end up with 47 times 2 divided by 5. So 47 times 2 divided by 5 gives me 18.8 centimeters. Okay, and I know that my units are centimeters because I'm keeping track of my units here. Kilometers and kilometers cancel, I'm left with centimeters. And that's exactly what I was looking for. Okay, so this is how we can use unit analysis, or our times divide method, to solve the problem instead of setting up as a proportion. Mind you, if we get stuck, we could always set this up as a proportion. It's a proportional problem. Oops, just zoom in here. We can always set this up as a proportional problem. We have our map distance, 2 centimeters to 5 kilometers. And then we have our 47 kilometers. And then we can solve this by, in this case, we're going to times by 0.4. So we could times by 0.4, and we'll get the exact same answer by setting it up that way. Okay, and notice that you see how we have our multiplier of 0.4 showing up right there as well. That's our unit rate going from bottom to top, the way we've set it up here.